All right. Hello, we are group 13, and today we will be presenting the history of smallpox. My name is Shayla Sori.
I'm David Font.
Hi, my name is George Surratt.
And I'm Victoria Oliva.
All right, let's get started. Okay, what is smallpox? Smallpox was one of the most dreadful illnesses in human history for a large portion of it. One of the pox virus family members, the variola virus, is the cause of smallpox, which is a highly contagious and fatal infectious disease. Because of its high fatality rate, intense symptoms, and quick transmission, it was one of the most dreaded illnesses in history. Close contact between individuals was the primary way that the virus spread, especially through respiratory droplets. However, it might also spread through contaminated clothing, mattresses, or surfaces. After contracting the infection, a person will go through an incubation period of about 10 to 14 days during which they will not show any symptoms. A high fever, exhaustion, headache, and back pain, as well as nausea and vomiting, in few cases appeared suddenly after this. And then after a few days, an unusual rash would develop, first on the hands, then the face, and then it will move to other parts of the body. Um, Red spots and elevated lumps and blisters filled with fluid, and ultimately scabs were the phases of the rash progression. In addition to leaving survivors with significant lifelong scars, the virus occasionally resulted in blindness, deformity, and even death in extreme cases. Smallpox has historically been one of the most deadly illnesses in human history, with a fatality rate of roughly 30%. Until the creation of an effective vaccination and global eradication attempt, its effects lasted for thousands of years. Okay, so now I'm going to be talking about the early history of smallpox. Smallpox is thought to have originated more than 3,000 years ago, making it one of the earliest known illnesses to human history. For instance, Pharaoh Ramses V is among the Egyptian mummies that have smallpox evidence. From then, the disease became widespread and lethal as it traveled across trade routes in Asia, Africa, and the Middle East. By the early medieval era, it had finally made its way to Europe. Over time, population immunity was acquired, but smallpox still caused a high mortality rate and devastating outbreaks. Also, the sickness took the lives of Tsar Peter II of Russia and Queen Mary II of England, proving that even royalty was vulnerable. This virus was unintentionally brought to the Americas by European colonists. Native populations were specifically at risk, because they had never experienced smallpox before. Whole villages were devastated by the epidemic, with mortality rates reaching 90% in certain places. This enormous death toll enabled European powers to conquer the New World and led to the demise of civilizations like the Incas and the Aztecs.
So I'm going to be going over the first research paper, which was titled Smallpox and its Eradication. The elimination of smallpox was a scientific breakthrough demonstrating how humans used virology to eradicate a lethal disease that killed about 300 million people in the 20th century alone. The creation of the vaccine began in the 18th century, when Edward Jenner discovered that milkmaids who had contracted cowpox seemed to be immune to smallpox. Jenner tested this theory in an experiment in 1796, where he extracted material from a cowpox sore on a milkmaid and gave it to a child, James Phipps. Surprisingly, when Phipps was later exposed to smallpox, he showed no signs of infection, which showed strong correlation between cowpox infection and smallpox immunity. Through this, virologists were able to develop an easily recreated version of cowpox to use as a vaccine. Vaccination initiatives began in the late 19th century and early 20th centuries, although they had encountered numerous obstacles. Vaccine shortages, insufficient refrigeration, and public fear and reluctance of vaccination in general were major obstacles. Next slide, please. Despite the working vaccine, smallpox was still affecting 10 to 15 million people annually. However, in 1958, the World Health Organization initiated a targeted campaign to combat smallpox. This idea resulted in an establishment of the Intensified Smallpox Eradication Program in 1967. These breakthroughs decreased the number of smallpox cases exponentially. These strategies implemented new methods that led to their eventual success. One such advancement was the creation of a freeze-dried vaccine that maintained its effectiveness without requiring refrigeration. Another significant innovation was the use of a bifurcated needle, which simplified the immunization process and required minimal training. Another method developed was the ring vaccination technique, which focused on vaccinating the contacts of infected individuals rather than the entire population. The final naturally occurring case of smallpox was identified in Somalia in 1977. After extensive monitoring to confirm the absence of new cases, the World Health Organization declared smallpox eradicated officially in 1980. This was, and still is, the first time that a virus was completely eradicated due to vaccinations. The complete eradication of smallpox demonstrates the potential of global cooperation, scientific discoveries, and coordinated public health activities. It acts as a model for future disease elimination attempts and highlights vaccines' revolutionary power in influencing the trajectory of human history.
I'll be presenting the signs and symptoms of smallpox and how it is spread from the moment that an individual is infected to the point that they are considered no longer contagious. We're going to start with the incubation phase, which happens after the individual has been exposed to the virus and it lasts about 7 to 19 days. During this phase, the individual does not show any symptoms and they are not contagious. After this phase, the initial symptoms phase begins, will last about 2 to 4 days, and at this point, the individual begins to experience high fevers, headaches, body discomfort, and it may cause vomit as well. During this phase, the individual could be contagious but not at the highest peak. The individual entered the early rash phase will last about 4 days, and it is considered the most contagious stage of the virus. It begins with a small red spots on the tongue and mouth, which later on this rash develops into the open sores filled with a white and yellow liquid. During this phase, the fever often returns, and after the infected individuals begin to experience the postular rash phase, lasting about 10 days, where the sores become pustules and later on begin to cross. During this phase, the individual remains very contagious, and after the scabs begin to fall off, which lasts about 6 days, the individual will still be contagious until all the scabs have fallen off. Next slide, please. It is very important to note that the infected individual becomes contagious at the start of the rash phase until the last one fall off. This virus has different ways in which it can be sprayed, but the most common ones are person to person. It could be through direct contact with the lesions as handshakings, hugs, and even with drops of saliva while talking with the infected individual, or even by touching contaminated areas or objects that they were touched by the infected individual, as bed sheets and door handles. Another way that the virus could be spread is through the air, especially in closed environments like hospitals and laboratory settings.
Now I'm going to be talking about the next research paper. That one is titled Virology Immune Invasion Proteins. This one just gives us an overview of the molecular mechanisms triggered by this virus. So, as we know, smallpox was eradicated in 1980 after a historic worldwide immunization effort. This immunization effort, as we know, is kind of a global achievement, as we mentioned in the previous slides, as it was the first virus that was finally eradicated through the uses of vaccines. But because of this historical significance and exceptional virulence, it is still one of the most researched and sought after infectious illness. The Variola virus, a member of the orthopox family, encodes approximately 200 proteins. In other words, the orthopox virus family, they are known to be a genus of viruses that cause raised and bumpy rashes. On a little insight, as a comparison, the flu only encodes for 10 proteins compared to the smallpox that has approximately 200. Many of these are specified for immune system invasion, These proteins are primarily located at the terminal regions of the genome and play a major role in the virus's ability to cause severe disease. Two important variola-encoded proteins that are essential for immune invasion have been classified by recent studies: the chromatin binding protein type 2, or in other words, CKBP2, and the smallpox inhibitor of complement enzymes, SPICE. Collectively, these compounds demonstrate the virus's complex tactics for invading host defenses and guaranteed viral reproduction and survival. A highly scaled virus that mimics humans' complement regulation proteins is called SPICE. By binding complement components C3b and C4b, it stops the development of membrane attack complexes such as MAC and stops their activation. By doing this, it promotes viral reproduction and protects infected cells from immune destruction. The virus's tight human specificity is supported by SPICE's exceptional proteins and unique adaptation to the human complement system. VCCI, or CKBP2, attaches itself to CC chromatin, which are molecules that typically direct immune cells to infection locations. CKBP2 shows inflammation and interferes with immune cell communication by sequestering these chromakins. The fact that CKBP2 has no known eukaryotic prologue, in contrast to numerous viral proteins, emphasizes its evolutionary distinctiveness. These proteins work together to show how variola disarms the intimate and adaptive immune systems on several levels. In addition to improving our knowledge on smallpox pathophysiology, research into their structure and function provides important information for immunotherapy, vaccine development, and the larger area of viral immune invasion.
All right. To summarize, smallpox was a fatal illness that was extremely contagious and brought on by the variola virus. Through the use of sophisticated proteins like SPICE and CKBP2, the virus demonstrated an amazing capacity to avoid detection by the immune system. An important turning point in medical history occurred in 1796 when Edward Jenner discovered the smallpox vaccine. In the middle of the 20th century, the World Health Organization began a worldwide eradication effort that lasted from 1958 to 1967. Innovations such as freeze-dried vaccines and a focused approach known as ring vaccination, which assisted in containing outbreaks, made this campaign successful. After a final natural case of smallpox that was documented in 1977, The disease was formally declared eradicated in 1980. All right, and thank you for watching, and I hope you enjoyed our presentation, and this is our references.